In order for us to understand machine learning, we need to know how the traditional programming works. Now remember when I said in machine learning we give the data and we give the output, which is the outcomes, and then the machine learning finds something called patterns in the data, and at the end it gives me the instructions or the rules of the program. Let me just start from all over again. In traditional programming, I give the data and I write the instructions, which is if and loop and all this stuff in programming, and the computer compiles it and it gives me the output. But in machine learning, I'm the one who's giving the data, but instead of writing the instructions, I give the output, and from that output and the data, the machine learning finds a pattern in it and it gives me the instructions. You'll be like, how? Okay, let's just go to the next slide here. If I am driving a car and I have three categories, which is one is overspeed, and then we have normal and we have slow. If I'm doing this, or I'm writing this program in traditional programming, I'm going to be doing it like this in if and else. If the vehicle speed is greater than 100, then the drive label is going to be overspeed. Else, if vehicle speed is greater than 40 but it's smaller than 100, which is between 40 and 100, the driving category is going to be normal. He is driving normal. Else, which means less than 40, is going to be slow. This is how it's done in traditional programming. I'm pretty sure you guys already know that. And the data that I'm going to give is going to be the vehicle speed. If I write 50 here, here's telling me if it's greater than 40 and less than 100 is going to be normal. So the after I enter the 50 and the vehicle speed, the computer is going to compile this code and it's giving me the normal. Okay, let's say I want to do the same thing in machine learning or deep learning. This is the outcome. This is what the program is giving me, and this is the data. Okay, this is the data, and this is the output or outcome. Here in machine learning, I'm the one who's giving the output. Now you'll be like, how I'm giving the output? Because I already have the data from the last year or from previous experimentation or something like that. And I'm the one who's giving the data here, the vehicle speed. I'm always giving the data in both ways. And machine learning and deep learning is going to find the rules or the instructions, which is this thing. This is the how it's going to find it, by finding pattern. Okay, let's say I have a bunch of spreadsheets. Okay, and let's say I have a spreadsheet here. It's called drive. Okay, drive speed. Okay, and then I have the outcome. Let's say drive speed here I have 50. Let's say vehicle 1, and the outcome is going to be normal. Let's say I have 150. According to this rule, if the vehicle speed is greater than 100, then it's going to be over speed, and so on. So this is the vehicle 2, and so on. Let's say I have the vehicle 1000 or 10,000. By feeding this data, the entire data, into the algorithms. Okay, this is the data, by the way. This data is this data, and these are the labels, the outcomes, which is here. And the machine learning is going to go and check. Let's say vehicle 1 was 50, normal. Vehicle 2 is 150, over speed. If there is a vehicle, let's say 999, it's 1 175. According to the rule or the pattern he found, if it's anything is higher than 100, I mean, I'm pretty sure there are going to be other data here, which is going to be, let's say, vehicle 844, which is going to be, let's say, 100 is going to be what? Normal, because there is an equal sign here. So let's say 157. Since the 150 is overspeed, obviously the 175 is going to be also overspeed, even though it wasn't there in the data. But by finding the patterns by itself, the machine learning algorithms found the pattern here, and he was like, you know what, according to the data that this guy gave me, anything is greater than 100, it was labeled overspeed. Since 175 is higher than 100, I'm gonna give it as an overspeed. Sometimes it makes mistakes. It all depends on the data that you give. Okay, this is how it works. Let's make a smaller example. Here in data I have two numbers. Okay, let's say x and y. X is 5 and y is 5. And the program is that I'm going to make in traditional programming is an addition program, which means I'm going to end up adding these two numbers. In traditional programming, since the instructions is like, let's say, x plus y equal to z, the output's going to be z. 10. 5 plus 5, 10. Simple, easy peasy. Same thing if I'm making on machine learning. I'm going to give him the data. As I said, I'm always giving the data. But instead of I give him the program here, I'm going to give him the output. So the machine learning algorithm is going to be like, okay, I have two numbers here and I have also an output as a number. So let's say 5 minus 5 equals 0. Is it the same as the output? No? Well, then subtraction is cancelled. Let's say 5 multiplied by 5. It's going to be 25. Is it the same as 10? No? Well, then multiplication is wrong. 5 divided by 5 equal 1. Is it the same as an output? Nope. So the division is cancelled. 5 plus 5 is 10. Is it the same as an output? Yes. Then the pattern that I found was addition. This is in simple terms, guys. Okay, let's take a real example. I'm pretty sure most of you got a smartphone. I mean, pretty sure some of you are watching this course on smartphone. And in smartphone, we have something called the weather widget, which basically gives me the data or the temperature for today, and for some reason, or I don't know how, is giving me for tomorrow, and on Saturday, on Sunday, on Monday, which means it's giving me the temperature for the 5-day forecast. I mean, how he knows that? I mean, I'm still in today, you know, I don't know, maybe tomorrow is going to rain, after that rain, cloudy, and then rain, and whatever. So how do they find this thing? I mean, how the weather for widget or the app works? Here he took the data from that last year. This is the date. This is the maximum temperature was on that date, and then minimum temperature and humidity and the rainfall, and the outlook, which is the output, is cloudly, which is written here. And same thing here. The data is going to find a pattern. Let's say if the max temperature was 43 and the minimum was 27, the humidity was 54, then and rainfall was 0, then there's a big chance that day is going to be sunny. Sometimes it's wrong, but most of the time it's correct. Same concept of this example, but in this data. This is how the machine learning is different between traditional programming. I hope it was clear. Thank you so much. See you in the next video.